It's 6 o'clock.
Yeah, I think we are live now. Ganesh, do you want to give an introduction?
Sure, Vishnu, thank you. Hi everyone, welcome you all to the 61st edition of Geeknight Coimbatore. Today we have topic Spark on Kubernetes. Our speakers are Dharani Soundarya, Senior Consultant in ThoughtWorks, and Gaushika Tirumurthy, Senior Consultant in ThoughtWorks. So for those who are new here, Geeknight is a monthly event to promote the sharing of technical knowledge and increase collaboration among geeks in Coimbatore. It is organized by a passionate group of programmers and sponsored by ThoughtWorks. So if you're willing to be a part in like giving a talk in upcoming edition of Geek Night, do let us know. We will be sharing a link in the chat shortly. So over to you, Dharani and Naushika.
Thank you, Ganesh. Quickly share my screen. Yeah. So hi everyone. Thank you all for joining this session. So I'm Kaushika, Senior Consultant at ThoughtWorks, and I have been in ThoughtWorks for around 2.5 years and with total 5 years of experience. And here we have, with me we have, Dharani, do you want to give an intro?
Thanks, Kaushika. Hi, everyone. This is Dharani Soundarya. I'm a senior infrastructure consultant, and I've been in ThoughtWorks for almost an year now. I have almost 6 years of experience, out of which I've been in DevOps and cloud engineering for the past 5 years. And yeah, looking forward to an interesting session today.
Thank you, Dharani. Yeah. So before moving on to today's topic, Spark on Kubernetes, we will give a quick intro on what Spark is. So Spark is a unified analytics engine that provides support for streaming, machine learning, graph computing, and Spark SQL data frames. And Spark does not have its own storage system. For example, if you take Hadoop, right, it has its own file system, that is HDFS. But when you consider Spark, it does not have its own storage system, but it provides integration to integrate with different storage systems that are available. So it claims that it can be 100x faster than Hadoop. That is possible because of two things. One is RDD and DAG. RDD is a resilient distributed dataset. With this, you can do a in-memory processing, because of which processing with taking data from disk versus processing in memory will be faster, right? So that is one reason. And also, when you submit a job to a Spark, it will not directly execute the instruction. Instead, it will optimize and represent the job in the form of a DAG. So with these two things, the Spark is faster than Hadoop. And also it provides fault tolerant. This is also because of RDD. Spark provides parallelism, and Spark is a master slave architecture, where your job will be running on multiple master node to provide this parallelism. So for example, while running your job, if one node goes down, the other node will take up the task and complete your job. So because of which the Spark is fault tolerant and with the help of RDD. So as I previously mentioned, it supports streaming support, right? It also provides support for batch processing. So based on your application need and based on whether you want real-time processing or not, you can use any one of this option that a Spark provides out of the box. And next is the Spark Core. Spark Core is a foundation for this platform, and this exposes an API which you can make use of in any of the 4 languages, Java or Scala and Python. So I think this might have given a quick intro of what Spark is. Next, we will see what happens when you submit a job to the Spark. So as I mentioned, Spark is a master slave architecture, right? So here it has 2 components. One is driver and the executor. Driver will act as a master, and whereas the executor acts as a worker nodes. So when you submit a job to a Spark, so actually you're submitting it a driver program will take care of submitting the task to the worker node, actually via the cluster manager. The executor nodes will process the task and return the result to the driver nodes. Once a task is completed, driver program with the help of cluster manager will terminate the executors. So we will see a quick this workflow with the quick example. So we all know that whenever we run an application, log plays a major role, right? So whenever there is an issue happens, we immediately look for the logs to see what happens. So consider you are having a log, application log in the HDFS. This is a log, the file location. So SC here is the Spark context. So with the help of Spark context, we are trying to get the file. And our major this problem statement is that we just want to get the number of Spark related errors, just the count. So first we are getting the file and filtering the file based on the error keyword. So now we have all list of logs with the error logs. Now we are filtering it based on the keyword Spark. So now we have the Spark related logs at only error logs, and we are getting the count of those logs. So whenever when you submit this job, the Spark will not simply execute each instruction then and there. Instead, what it does is that until it notices this executable function, that is count, it will just get the inputs, and just and after noticing this executable function, it represents the job in the form of a DAG, that is the flow in which your job will be executed. And driver program will be passing or submitting the task to the executor. Executor will perform the task and return the result to the driver program. So now we know what is a driver and executor. We have mentioned that cluster manager is the one with which driver program will be creating or managing the executors, right? We haven't specified that what are the cluster manager that Spark supports. Actually, Spark supports 4 cluster manager. The widely used one is Yarn. Yarn is a JVM-based Hadoop resource manager, and this has been widely used for Spark, whereas Mesos and standalone cluster managers are not that widely used when we compare to Yarn. When we consider this standalone as a cluster manager, that has only limited features when you consider Yarn or Kubernetes. And Kubernetes has been recently used by most of the applications. And with Spark 3.1.2 release, Kubernetes has been acknowledged to be used in production setups. So now we know that as Yarn has been widely used, we have a question of why we want to run Spark on Kubernetes. So next we will be discussing on what are the issues that we are facing or the shortcomings that we are facing with Yarn as a cluster manager. So actually Yarn can, as a cluster manager, you can use in both on-prem and as well as cloud. And there are different tools that can use for different purposes. So here in this session, we will be discussing only on the managed service. Consider EMR, that managed service that is provided by AWS, or the data prog that is provided by GCP. So one major issue that we see is that Spark version. The Spark version is dependent on the managed service release. For example, if you take EMR, that is a managed service provided by AWS, and also, for example, if you take, there is a major release that is made by Spark, and that is and it has an interesting features, you cannot directly make use of it. You have to wait for this managed service to release a version, and then only you can make use of that features. So we are heavily dependent on their releases, and it also does not have dependency on performance isolation. That is, so there are 2 ways in which you can run the Spark in the managed service. That is, create a cluster and run all your Spark application in a single cluster. So in that case, all application should be making use of only a single version. Or if you want a different version for different application, you have to create a different clusters for it, right? And also, if you're running multiple application in a one cluster, when a one application use most of the resources, the other application will not be able to perform. So there will be some performance issues as well. So this is with the one approach, that is creating one cluster for all Spark applications. It also provides another option, that is, whenever you want to run a job, create a cluster, run the job, and terminate the cluster. With this option, we see a lag where we have to create a cluster every time, which might take 5 to 10 minutes. So you have to wait for it or monitor it, then only you can submit the job. So these are the 2 issues when you create a cluster for running a Spark, and it is not a cloud agnostic. For example, if you're written a code to run a Spark application in AWS, so later you want to run it in GCP or Azure, you cannot directly use the code that you have written for AWS. You have to make some changes to it. So it is not cloud agnostic. And for example, if you have an application that needs to be run on both cloud as well as on on-prem, so we face this scenario where we have a Spark application we need to run on support on-prem as well. In that case, we created a separate code base for code for it, and it also adds an additional maintenance effort for maintaining two different code bases. So these are the major issues that we have faced when we were running Spark on managed services. So yeah, okay. Now we have a question of whether these issues will be solved, or what are the additional advantages we get when we run Spark on Kubernetes. So one major advantage that we all know is the containerization. So if you are already running your application in Kubernetes, you know about this advantage, right? So you just need to write an application that will be that you can scale in or scale out based on your need. It is just a simple configuration change, right? And also launching an application will also be quicker when you compare to cluster creation. This is much faster than that. And also, if you want a different Spark version for different Spark applications, then you don't want to create a different cluster for it. You can create different images and create a different container for different applications. And also the major issue that we saw with the managed services is that it is not cloud agnostic, and it cannot be used, same code cannot be used in on-prem. With this, we can overcome that, where we are not dependent on a particular vendor. And also it provides additional security features, like you can do role-based access control. And also if you want any multi-tenancy support, you can do it very well by using namespace and quotas. So it provides an additional security features. Okay. And also whenever you run an application, right, we want to view the logs, and also centralized viewing of the logs, and also you want to monitor the performance of the application, right? So for that, if you're running Spark on Kubernetes, it provides an easy integration with the existing tools like Datadog or Prometheus. And it also has a strong community support. So whenever you have an issue, you can just raise an issue for it, and that can be resolved. So it has a strong community support. So these are the advantages, or the advantages that we get when we run Spark on Kubernetes, and also the issues that we were facing with the managed services that can be solved with this Spark on Kubernetes option. So you can run Spark on Kubernetes in different ways. These are the few ways in which you can run Spark on Kubernetes. One is using the plain Spark submit command. There is also a Spark Kubernetes operator, which is developed by Google, and Thrift, Livy, Zeppelin, and Vue. So as part for this session, we will be looking at plain Spark submit and Spark Kubernetes operator. Any questions so far before moving on to the next?
So Gaushika, I see a question on the chat. This is regarding the code that you shared, I think, in this third slide. Spark.count is the executor, right? That's the question that has been asked.
Yeah, a Spark.count is not an executor. This is just a method that is provided by a Spark. So similar to how we are writing a query in the DB, right? Select count of star from like that. This is a function that is provided by Spark, which will be executed by the executors, and it will be written to the driver pro. This is not an executor. Yeah, maybe. Is there any other questions, or did I answer your question? Yeah, right. Spark in this slide is just a variable name that we have used. Yeah, Prakash. It is a data frame. Okay. If there are no questions, we'll hand it over to Dharani.
Thanks, Kaushika. I'll go ahead and share my screen. Okay, So now that Gaushika has covered all of the advantages of running Spark on Kubernetes, right? We'll look into what we should do in order to run the Spark on Kubernetes and what exactly happens when we submit an application, right? So think of you as the client, like we are going to submit a Spark submit job. In a typical scenario, maybe in a managed service, we'll be submitting, and in this case, we are submitting it to the Kubernetes API server. So what happens inside here is that Kubernetes takes that request and then it schedules the driver pod. Driver pod is where the main function, like in case of Python or Scala or Java, whichever program that you're running, its main function will run inside the Spark driver. This Spark driver then you'll also submit an application code along with this, and this Spark driver would then request the Kubernetes control plane for more executors. So the executors is where the action happens. This is where the code is executed and you get the results. So once the code is executed, the application, and you get the desired result, all of these executors get terminated, and then the Spark driver pod will go into a completed state. It will remain in the completed state unless and until someone goes ahead and manually removes the driver pod, or if it is garbage collected by the Kubernetes setup, right? It might, if you're new to this, it might look a little bit confusing, but when we show a demo, you will be able to clearly understand. Okay, so the advantages of having this vanilla Spark submit. So whatever we did here is we are calling it as vanilla Spark submit. The advantage is that it is not dependent upon the Kubernetes version. Like for example, Kubernetes has its own versionings, right? 1.19, 1.18. It is not dependent on it. You just submit a request to the Kubernetes endpoint. You have to provide a Spark base image. So the driver pod has to spin off of some image, right? For that, you have to give the Spark base image. You do not have to define any Kubernetes resource. Let's say you are someone who is a beginner and you want to experiment with the Spark on Kubernetes, right? You can go ahead and then using a simple command, you can submit your Spark application, and without any config maps, volumes, RBAC, all of these concepts of Kubernetes, you can directly submit it and still it will run on Kubernetes. But we are not using it in production a lot because we do not want to get into a Snowflake kind of a setup. So we use it mainly in order to test the Spark base image or the application. So once we've tested it, we usually go for other ways in which we can submit the Spark jobs. Right? There is something that we have to do though before doing this vanilla Spark submit. You have to have the Spark base image. So constructing this base image is straightforward. It is documented in the Spark default Spark documentation, and you'll be able to see how you can build that image. And you have to have a namespace inside the Kubernetes cluster, but it is optional. If you do not specify a namespace, the driver pod and executor pods will get spun up in the default namespace. So now, like I said, when you submit a Spark job, the Kubernetes control plane will create a driver, but then driver requests for executors. So drivers should have permissions for that, right? So you have to have a service account assigned to the driver with necessary permissions. Again, you do not need to know a lot about it. Just these two commands that I'm showing in the slide is enough. When you execute this command, it will create a cluster role and a role binding and then attach it to the service account. And then you have to have the binary in your local. So using, there is a folder inside the binary from which we are going to execute this Spark submit command. So I'll quickly show you a vanilla Spark submit. So before we jump in, 1 second. Yeah. As you can see, this is the command. As simple as that, you can build the base image for Docker, base image for the Spark on Docker. And once you have built that image, you can push it to your set of registry. And using these commands, you can create the respective service account, cluster role, and cluster role binding. For the benefit of the time, I have already created the service account before the call. So we can do the vanilla Spark submit or the plain Spark submit as we are calling it. So before that, let's go through the values inside here. So we have to specify in our case, since we are submitting it to a Kubernetes endpoint, this is the Kubernetes API endpoint. Since I'm using EKS, this is an EKS endpoint. In your case, it can be Minikube, it can be GKE, or it can be any of the Kubernetes clusters that you have. And the class SparkPy stands for the application that I'm going to submit. And deploy mode, you can have client or cluster. In our case, we are going to go with cluster. And like I said, you have to create a service account, and I'm pointing to that service account. I have created it under the name Spark, and I'm pointing it to the service account. You have to point it to the image. Like I said, when you build an image using these commands, you will get an image, and you have to point that image, out of which the drivers and executors will be launched. And it will be launched in the namespace. This is optional, but in order to not disturb other namespaces, I'm giving my own namespace named Spark. And Kubernetes file upload path, I'll come back to this point later. This point, Spark event log enable, Spark history.fs log directory, Spark event log directory. These three are necessary for pushing the logs of the application that we are submitting to S3. Why do we need it? I mean, this is optional. There is no need and there is no necessity to add it. For testing, you can skip it. But why is this necessary? I'll explain in a minute. And then this is the jar in which through which we are going to submit the application. So just a second. Okay, I'll quickly copy this Spark submit. And then, so now what I've done is I'm watching the space of namespace Spark. K stands for kubectl. I've just created an alias here. K get pods. We are watching the namespace. We are seeing if any of the pods are getting created. I'm just going to submit the Spark submit command here. Yep. Sorry, I'll quickly go into the folder. As you can see here, the driver pod got created and it is in running state. Now what is happening is it is creating the executors where the application is getting executed. So what we are doing is we are calculating the pi value through Spark, and we are trying to see if we are going to get the pi value through Spark. As you can see, the driver came into completed state and all of the executors that were launched went into termination. Let me quickly show the logs of this driver pod. So if you can see here, pi is roughly 3.1.140. So using Spark, as simple as that, with just a simple command, we have submitted a job and we have identified and got the value of the pi. So this is the vanilla Spark submit. I'll go back to the slide. Any questions before we jump in? Yeah, so if the data set size is huge, is there a chance the driver's memory is not enough and the pod dies off? So in this case, what we can do is we can use a cluster autoscaler or a pod autoscaler and then make sure that the cluster is auto-scaled and has enough space for the drivers and executors to launch in there. But as far as I know, if the driver is killed, there is no feature at the moment to deal with that sort of issues. We have to make sure that the driver is not killed because that is where the main function runs. So do we have any other questions? How to run Java code on a Spark cluster without jar files in Spark Launcher. So with respect to the jar files, if you have any of the, so if there are any jar file dependencies that you have, Spark allows it, like there is a configuration for that. You can use that configuration and then you can point those jar files, or you can upload the jar files to an S3 bucket and point to them while you are going to work on Java code. So another thing that I forgot to mention was, let's say in a typical scenario, right, we are just using the Spark base image. In your scenario, what you would be doing is you would be baking that jar file and dependencies and your application code in the image, and you'll be giving that image and you'll be calling that jar or that application directly. So that is also possible. So the same image will work for Scala, Java, and Python. how to run Java code on a Spark cluster without jar files in Spark Launcher. I'm not sure what jar files you mean. And when you say Spark Launcher, do you mean the binary of the Spark, Ashmit? Okay. Okay, I'm not really sure about that. Maybe we can get back to you on that. Okay. So we'll go to the next part. Okay, so now we've went through the vanilla Spark submit setup, right? We can also submit a job to Spark cluster using the Spark operator. We wouldn't call it a Spark cluster, Kubernetes cluster with using a Spark operator. So what are the advantages of Spark operator is that it is open source. Before we jump into advantages of Spark operator, I want to give a quick introduction on what operator is. So if you worked in Kubernetes, Kubernetes has its own set of configurations, right? It has pods, it has replica sets, deployments and all that. But let's say if I want to extend the configuration of the Spark operator, if I want to extend the configuration of a Kubernetes setup, right? For example, we have Java. Java has its own inbuilt functionalities and inbuilt setup. Let's say if I have to extend that functionality, and what do we do is we create jars and then we add those jars, and then like we do the normal Java basic setup, right? We usually import those jars and create functions on top of them. Similarly, if we want to add additional functionalities to Kubernetes, very specific custom functionalities to Kubernetes, there is a concept called operators, Kubernetes operator. In a similar fashion, the folks from Google have created the Spark operator to offer a native Kubernetes experience. So there are some disadvantages with the previous approach. So in order to overcome that, they have open sourced this Kubernetes operator under the name Spark on Kubernetes operator. You can find it in GitHub. If you just search Spark on Kubernetes operator, you will be able to find it. So advantage of using this is that you can enjoy the full range of Kubernetes. Like you can use the config map, secrets, env, volumes, volume ounce, whatever you want there. You can utilize all this because the Kubernetes operator setup is using all of these, and you can make use of all that in order to customize your setup as accordingly. So it is easy to maintain with proper version control. The way to submit jobs to a Spark operator, I'll quickly show in a minute, is through YAML files. And because of having these YAML files, you can easily version control, and it stands as a documentation for the jobs that you're running. Let's say you have multiple, more than 50 or 100 jobs that you're submitting to the Spark cluster, right? All of it can be in YAMLs, and you can, have a proper version control for all of these YAMLs, and you'll have a backup and documentation for the jobs that you're running. So it supports out-of-the-box monitoring configuration. We do not have to do anything. Prometheus, you have to set it up, but for support for Prometheus, for exporting the Prometheus metrics, you have an out-of-the-box monitoring configuration. All you have to do is just go to the values.yaml of the Helm chart of the Spark operator and enable it, and out of the box, you will get the metrics exported in the Prometheus format. Of course, it follows industry best practices and is constantly updated by the community. It has a lot of pending PRs, merged PRs every day. So it is constantly maintained, and they make sure that it follows the industry best practices. And the documentation is detailed and easy to understand. Trust me on this. Like, we've spent a lot of time trying to, set up the Spark operator in our way, and we've always found the answers in the Spark documentation. Like, it is complete, it is very detailed, and we are able to get all the info and all the associated details easily in the documentation. And how does Spark operator work? This internally, it also uses Spark Summit, just that they have templatized it in such a way that they've made it easy for us to, submit jobs through the Spark operator. Again, like vanilla Spark Summit, Spark operator has its own checklist that we have to have before running the jobs on it. So we have to have a namespace, again, optional. If we do not specify it, it will get launched in the default namespace, and default namespace might not have permissions, and that could be a problem. So it's always best to go with the namespace for the operator. Namespace for running the Spark jobs. Again, you can still run the Spark jobs in the same namespace as that of the Spark operator, or you can create separate namespaces for your Spark jobs depending upon your input. Again, the same service account to assign to drivers so that it can create the executor pods. A role and role binding necessary in order to associate with the service account. Other optional configurations that you can do on Spark operator is you can have a Prometheus operator set up in the same cluster and then take these metrics that Spark is exporting, and then you can do anything with it. You can, create alerts, create dashboards using Grafana. All of that is possible. You can have an S3 bucket or other storage setup. Why? Because let's say you are submitting a job to the Spark operator, right? You want to see the status or the metrics of the past jobs. In order to see that, if you push the logs to an S3 bucket, you can use history server. There is something called as a Spark history server. Using Spark history server, you can see the past jobs, metrics and stats related to that. And some kind of a logging setup to push the logs to a central collector. Other logs, not the Spark logs. Spark logs will be taken care of by itself if we specify the configuration. Other pod related logs, right? Okay, so I'll quickly go to the demo of the Spark operator. So let's say if all of this sounded a little bit, how can I say, complicated, and you want to try out, it's as simple as these two commands. With these two commands, you will have a running Spark operator with all of the advantages that we just talked about. So what we are doing is we are going to add a Helm repo. We are going to add a Helm repo for the Spark operator. I've added it already. Let me clear the screen. So it will say it already exists. In your case, it will get added. And all I have to do is, let me clear the screen, get pods in Spark. I'm just going to watch in order to see if the Spark operator gets created here. Helm install, I'm going to install the Spark operator in the namespace Spark, and it is named as Spark operator from the repo Spark operator. That's what this means. So within the simplicity of these two commands, right, we have a running Spark operator with all the advantages that we just mentioned. So how can I submit jobs to the Spark operator? Like, for example, operator is running. Now we have to submit jobs to the Spark operator. Then Spark operator on our behalf will submit the job, right? So for that, I just took this PyPy YAML file. Again, this PyPy YAML file is there in the Spark on Kubernetes operator examples folder itself. If you go to the GitHub link of that Spark operator on Kubernetes, right, you'll be able to get this under the examples folder. As you can see in here, it says Spark application. Usually in your typical Kubernetes manifest files, right, you'll see names like pod or replica set or demo or service or anything like that, right? But since it's a custom resource definition, since it's an operator, this is a Spark application is a custom resource of the Spark operator. That's why we have kind as Spark application. And like we saw in the vanilla Spark submit, we are going to submit the main application file, and we are going to submit it to this using this image through which the drivers and executors will be launched. And using these, like for example, core limit, memory, instances, cores, you can control the resources that the drivers and executors are using. Apart from this, you can also see some Prometheus related configurations here, right? So as simple as adding these Prometheus related configurations. So Spark will start exporting the Prometheus metrics in the port 9091. And if you have a Prometheus setup, all you have to do is just scrape these metrics at this port under the /metrics endpoint, and you'd be able to see the metrics in the Prometheus dashboard. Right? Does it make sense? Cool. Okay, I'll quickly go to that location. Let me go to that. I'm going to apply this file, and I'm going to give the namespace in which I'm going to create this. As you can see, since it's already there, it's giving me this error. Not an error, but it's saying it's already exists. Let me delete the one that is already there. So it's deleted. It's created. As you can see, the PySpark Pi driver started spinning up. Again, this is the calculation of pi value. We've just used the default example to make it simple for this demo. As you can see, the PySpark Pi driver is in running state, and it has created the respective executors. Now the executors are in running. If we want, we can tail the log of the driver in order to see the output. As you can see, I think it's already done. So all of them got terminated and the PySpark PyDriver went into completed state. And in order to see the solution for this, right, we'd be able to see these are some of the, since we enabled the Prometheus metrics, they are showing up. I'll quickly show pi is roughly 3.140280. So it has calculated the pi value. So as simple as 3 commands, we've submitted a job to the Spark operator and we've gotten the result. Now, there is a practical problem here, right? If you know about Spark, you would be able to see the driver UI. Let's say, why do we need the driver UI is if we want to see the metrics of the job or the stats of the job, we would go to the driver UI and see it. But in this case, the driver went into a completed state. When it goes into a completed state, it does not occupy any resources in the cluster. It means that it occupies 0 resources. Then how can we see the stats or the metrics of the jobs that we have run? So that is where the history server comes into picture. So again, history server is an internal Spark component. So what would happen is that in the previous example of the vanilla Spark submit, if you remember, I showed you a location for the fs log directory, event log directory, right? What I've done is I've pushed the logs of this job to this particular location, my a bucket, and then under there test and logs. So now I have a history server. What I would be doing in the history server is I would be pointing to this location. So what would happen with that is that history server would be able to give me the stats, the metrics of the jobs that we have run, the time it took, the DAGs related to that, all of that we can analyze and then maybe make some changes in order to have a better performing setup. So Spark History Server is a monitoring tool that displays information about completed Spark applications. This allows us to review the application metrics after the application has completed. History Server can be launched in Kubernetes as well, and we can point the config to the same location where we have pushed the logs when submitting the Spark jobs. This can be templatized. So what we have done in our setup is that we also have launched the history server in Kubernetes as Helm charts, and with like I said, as simple as couple of commands, we can launch the history server as well. So history server would look like this. I'd be able to show it in the demo. So just in case if the demo might, if the demo gods are angry, we might not be able to see it, right? So just in case I took a screenshot for the history server and then I added it here. So this is how it would look. As it will be pointing to the event log directory, and then it will show all of the jobs that we have submitted and the past jobs, the time it took. And if you go into any of these apps, right, you'd be able to see into more details. Right. I'll quickly create the history server operator as well. And like I said, it is pretty straightforward. We've templatized it using Helm chart. And I'll quickly go to that repo. Okay. So what I'm going to do here is, let me clear this up. Right, as you can see, Spark operator is running. It shows PySpark and the past jobs are showing as completed. Now I'm going to install the history server in the same namespace, which is Spark. As you can see here, history server is spinning up. And it is getting into running state. In order to see the UI, what am I going to do is that as part of the Helm chart, it also creates a Spark history server service. So what am I going to do is I'm just going to do a port forwarding for this so that we can see it in the UI. So history server shows its output in the port 180180. That's why I've added the 180180 port. Let's wait for the history server to come into running. If you can see here, history server has come into the running status. Okay. It is loading the history summary from the event log directory that we just pointed to. And if you can see here, 17 to 2022, it shows the recent job that we submitted using the vanilla Spark submit, and you'd be able to see more details. You'd be able to download the event log. So even though the pod is not there, you'd still be able to see stats and metrics related to that job. So you'd be able to see how much time it took, and also the time when it launched the executors, the time when it created the drivers and executors, respective drivers and executors. You can also see the DAGs as well. 1 second. Yeah, if you can go to one of them, right, you can see the DAGs. So using this, what you can do is you can make sure that you can decrease the number of shuffles that the job is taking. So it will show the shuffles it does during the Spark job, and reducing the shuffles would reduce the latency for us, and that way you can optimize your Spark jobs in such a way that you can reduce the number of shuffles and then improve the performance of the jobs that you are submitting. Any questions, folks? Okay, I'll go on to the next section of this. So there are some best practices and security related to security and the lessons learned that we had while deploying the setup. There were also some of the points that we are still working on that we've taken from some of the recommendations from, there was one really good blog on K8S Spark performance by AWS. So maybe you can go and check it out. They have a proper code base where we can run performance tests on the Spark setup and identify the time it takes and maybe optimize the whole cluster and setup. So there they had mentioned that the Spark on Kubernetes has caught up with the speed that the Yarn as a cluster manager has, and it has more detailed explanations on how we can improve the performance of our cluster resource and cluster setup. So we'll see some of them here, and also some of the best practices in security that we did. Right. So again, do a performance test to identify the resources that you allocate for the Spark executors, because it can go out of hand. If you have the dynamic Spark executor allocation enabled, it can go out of hand, and it might strangle the resources that are present there for other applications. So we have to make sure that we assign certain service level quotas or namespace level quotas so that the executors do not cross that limit. Also, we can identify the cluster size for a typical job application, right? So we can do that. And then, so YAMLs, if you start working with YAMLs, if anyone of you has worked with YAMLs to Kubernetes and not with Helm, you'll know how frustrating that is, because it will go into thousands and thousands of lines of YAML of repeated code. So we have to use Helm charts in order to not get caught in the YAML hell, and templatize it as much as possible. So this is with respect to the question that was previously asked to. So we can, to avoid the OOM, which is the out of memory errors that usually we get, we can use the cluster autoscaler along with the pod autoscaler and scale up the pods and the respective cluster nodes so that it will have enough room to spin up all the executors as and when needed. Okay, another suggestion is that executors can be run on spot instances, but make sure that the driver is not scheduled in the spot instances, because like we said, if driver gets terminated or we will lose the data related to that. So because that is where the main function is running, so we have to make sure that the driver remains in maybe an on-demand instance and the executors can run in the spot instances. And we can achieve this using the node affinity, stains, and tolerations that the Kubernetes offers. So in order to prevent, so we talked about cluster autoscaler, right? A typical scenario of a cluster autoscaler is when there is a lot of load, the pod or the nodes of the Kubernetes cluster will increase. At the same time, when there is a decrease in load, it will decrease, right? So in order to protect your driver pod from not terminating when the scale in happens, you have to add this annotation in order to prevent the driver pod from not getting terminated. What this will do is this will make sure that the processes that are there in the driver pod are drained before it terminates the node, and then it will launch the driver in the next node, whichever is available. So another thing as a best practice is that there is no need for you to spin up a separate Kubernetes cluster for your data workloads. If you already have a Kubernetes cluster that you are using for your other application setup levels setup, you can definitely use them as well. You can just create separate namespaces, account, service account, and you can run multiple versions of Spark within the same cluster as well. Now 3.1.2, or if you are familiar with the older versions of Spark, you can run all of them in a single EKS or any cluster. It's not related to EKS, any Kubernetes cluster. When I say EKS, it is the Elastic Kubernetes Service of AWS. Yeah, this was one that was suggested in the AWS documentation, is to run the Spark workloads in a single AZ. Why are they saying that? Is that they have found a decrease in the latency. So basically what has happened is, instead, with respect to the cross AZ and a single AZ, they found out that in case of a single AZ, the latency has gone down from milliseconds to microseconds. Another thing that we have to keep in mind is that AWS in particular charges the data transfer cost that goes in and out of an AZ. You will be paying $0.01 per GB of all the data that you are passing in and out of the AZ. So let's say you are estimating for your cost estimating in order to move to a Kubernetes setup, right? You might miss that. Data transfer between multiple AZs is added to the bill. So make sure, it's not like make sure, but keep that in mind while launching your cluster, so that when the shuffle happens, right, a lot of in and out operation happens between the pods, and if they reside in a single AZ, you can save a lot of money. But you can also, if availability is a big factor, you can ignore that, but this is a way to save money as well as to decrease the latency. Okay, another one important recommendation is that when you are doing when an application is being executed on, right, the execution happens in the container writable storage. So container or each of these containers that we have, right, that has a writable layer, and that's where the shuffle or whatever operations that you do that you comment happens. Ideally, we do not want this scenario, right? We do not want the container to be overloaded. So it is recommended to use an empty directory. Empty directory is a Kubernetes and Docker specification where we can mount the host, basically the nodes, file system or volumes, or maybe even the memory of the file system where the pods are running to the pod. And that way we can improve the performance, improve the speed as well. But be very careful if you are going to mount the memory of the file system, right? There is a very high chance that you might get out of memory errors. You have to be very careful. Another recommendation is that if you are going to mount a particular directory or a volume, then you have to be careful in a scenario where, not careful, keep in mind in a scenario where, in case of AWS, right, all of these instances will reside in a rack. The compute instances will reside in a rack, and the storage devices will reside in another rack, and they will be connected through wires. So this is how usually the setup happens. But in order to avoid, there will be a latency because of this connecting wires, right? In order to avoid it, what we can do is we can use something called as an instance store volumes. What this instance store volume is that the drive, the storage is attached directly to the compute instances. So we can reduce the latency of the or the time taken for the IO, right? That will be happening. So usually these instance store volumes will have a high IO, and the offering on that is NVMe SSD. But one thing that you have to keep in mind if you are using an instance store is that it is volatile, in the sense that if you stop the instance, you will I mean the data that is there in the instance store will be lost, unlike an EBS, right? In case of an EBS, you can still have the data, but if you're having an instance store, we call it volatile, and you lose the data. So unless and until you're not worried about losing the data, go for an NVMe SSD as storage volume. So of course, we've had a long talk now discussing all the advantages and the ways that we have, ways of submitting jobs, Kubernetes and Kubernetes this, Kubernetes that. But definitely there are some cons to running Spark on Kubernetes. And that is if you are someone who's new to Kubernetes, there is a steep learning curve. You have to, handle everything. You have to handle the management of the pods, auto scaling, replica set, daemon set, high availability, everything. You have to take care of it. So you have to manage a lot of components. And also, if you consider the cost, let's say you already have a managed service and you go for a Kubernetes setup, and this Kubernetes setup is also a managed service, self or no, half managed service, like an EKS, let's say, you would not save a lot of money. In fact, both of them are kind of equal in the cost estimate. You will save a lot of money, let's say, if you are going to use maybe a COPS cluster, or even your own, if you already have a Kubernetes cluster and then you are utilizing it, right? In that case, you will save money. So you have to manage a lot of stuff. If you're not familiar with the setup, it might get a little how can I say, a little confusing for you in the beginning, but you'll definitely get used to it. You have to think about secure setup, SSL, communication, networking, all of this you have to handle. So what we are trying to tell from this whole talk is that if you can see in the traditional architecture, right, almost all of the softwares that we have been using for a while has been slowly moving to containerized applications. And from there, we are moving to orchestrators that can handle these containerized applications. In a similar fashion, in the data world as well, we are seeing a shift where all of the softwares, all of the related products are slowly moving towards containerized environments and orchestrators that will handle these containerized environments. So even in our setup, right, in our project, we have containerized Spark, History, Hue, Zeppelin, Atlas, all of these we've created Kubernetes and then the respective Helm charts. So it is inevitable. So it is right that we start, getting to know this landscape and then maybe get into it and then explore, so that, we are not left behind in the setup, right? So any questions? Sure, Ashwath. Yep. So with respect to DAGs, rather than me, you can find a lot of YouTube videos where they explain about DAGs and how we can optimize it, how we can improve the performance. This is out of scope for this call, so maybe if I find the link, I'll share it to you. So Gaushika, do you know the answer for this question that Ashwit is asking in the previous one, how to run Java code on a Spark cluster?
Yeah, we have tried with jar files, Dharni, but we haven't tried without that.
Okay. Yeah, even I'm not sure, Ashwit, on that. We'll get back to you on that, but thank you for asking. Is there any other questions that... So Ganesh, if you are there any questions in the chat of YouTube?
Yes, sir, I'm looking for, but I think there are no more questions.
Okay, cool. Thank you so much, everyone. Thank you so much for joining and for asking all these questions. Over to you, Gaushika.
Yeah, I just want to thank you, everyone, for joining us. Thank you.
Okay, have a good evening, and yeah, thank you.
Yeah, thank you, Dharni and Kaushik.